Okay, every student, let's start the second sections of today's lesson. Okay, actually, from this part, we are going to learn the fifth section, section 5 of our syllabus. Okay, and it is the last sessions in Form 4 studies. The section actually, the title is fossil fuels and carbon compounds. Still remember, I have told you because we have so many different kinds of compounds. So the chemistry syllabus will divide different kind of compound into four categories. And we have already learned the first category is metal because it is the most important elements. Okay, out of 100 and more than 10 times 80 kind of elements, metals. There are 80 several kinds of metals. And the second category is acids and alkalis. We have already learned. Okay, and the third category goes to carbon compounds. If you still remember, in the first several lessons, I told you that there are more than 40 million kind of compounds, and carbon compounds more than three four, third, more than 30 million kind of compounds are carbon compounds. There are so many different kind of carbon compounds. So how can we learn carbon compound more systematically? Actually, the following chapters will teach you how to do it. But actually, carbon compound will divide into two parts. Okay, actually in this section we are going to learn the first part, but we will learn four different kind of carbon compounds. How can we learn so many different carbon compounds more systematically? I will tell you in the following chapters. Okay, but why the titles of this section also include fossil fuels? Fossil fuel in Chinese, 化石燃料. That means usually we talk about coal, petroleum, and natural gas. It is because actually nowadays most carbon compounds are come from. It is the raw materials of carbon compound. Okay, so why the first chapters, the section, the name of the section is fossil fuels and carbon compound, and we know that carbon fossil fuel is so important for modern life. Okay, how can it be used? How can it be refinery? That means because actually when we find or we try to extract the fossil fuels from the earth, actually they cannot be used directly. How can we refine it? How can we make it more useful? And also, what is the uh, consequence? That means the side effect. Consequence of using fossil fuels. Actually, in your liberal study, you have you may know many consequence of using fossil fuels. And actually, in chemistry, we will use the chemistry knowledge to try to understand why those consequences are so bad to our environment. Okay, and because it is the raw materials of carbon compounds, before learning what the chemical properties and physical properties of carbon compounds, we will learn the raw material first. Okay, we know how the carbon compound is come from. So why the section name is fossil fuels and carbon compounds. And carbon compounds are in previous years, it is also called organic compound. So sometimes in the notes or in your daily life, you will see these terms, okay, organic compound. Uh, but nowadays, because not so many carbon compounds are organic. Organic actually it is come from living things. So because Nowadays, most carbon compounds are come from coal, petroleum, and natural gas. They are not come from living things. So we change it into carbon compound. It is because all organic compounds should have at least carbon as their main ingredients, as the main part. So why they are called carbon compound? And why there are so many carbon compounds, and how can we systematically learn carbon compounds? I hope you after this section you know how to learn this category. Okay, so first of all, we these chapters we are concentrating in fossil fuels. Okay, uh, fossil fuels, it is the most important energy source. Okay, still more than half, or more than maybe 60 to 70%, and depends on countries. Some country maybe mostly depends on fossil fuels. But nowadays we know that we have some solutions to try to replace the use of fossil fuels. You have learned it in liberal study. Okay, we have many other energy sources. We hope that they can replace the use of fossil fuels. Uh, then we can use fossil fuels to do other things, not just to burn it. Okay, how can we obtain energy from fossil fuels? We need to burn it. Okay, the burning is a chemical reaction. So why we study it in chemistry? Okay, uh, the three main sources. Okay, and why they are called fossil fuels? Because they come from uh, the living things many years ago. Sometimes you will ask why they are called living fossil fuels, and sometimes you will be separate asking about the source of petroleum. Actually, petroleum and natural gas come from the main same source, and you will also be asked about the source, how code is come from. So actually, I have highlight the answer. Okay, for code, remember it must come from plants here many years ago, millions years ago. They die and covered. Actually, they will not directly change into code. They must using some energy to make it. Usually, it is the energy come from the earth. Okay, it is covered by soil, and then the soil, because it is covered by many soil, heavy soil, so it will exert, it will have some high pressure on it, and also high temperature. When there are a high pressure, usually it will also has a high temperature. It will also need the help of bacteria, the action of bacteria. Three factors together, okay, they will slowly change into substance, coal. And coal is mainly, maybe sometimes more than 90% is carbon. It will also contain some other impurities, okay? Also contains maybe some metal, calcium carbonate, calcium rocks, okay? And one of the bad, the most worst impurity is sulfide. So later we will taking care of how what is the consequence of using burning coal, because it contains sulfide, and this is the not a very good impurities. Okay, so remember it will be asked sometimes. Okay, actually it is come from plants many years ago, and three actions: high temperature, high pressure, and bacteria actions. Okay, and it will slowly change into mainly carbons. Okay, it is the origin of coal. The two diagrams show you how coal is formed. So actually, usually coal is underground. So how can you uh, extract? Okay, coal you should dump into the ground. Okay, maybe many meters. Okay, meters. Okay, underground. Okay, so why usually the coal mine is underground? Okay, nowadays, the use of coal is used to burn. Okay, in power stations, Hong Kong is also using coal, burning coal to generate electricity. Uh, Not many different kinds of other usage of coal. Okay, and of course, in some country, they will directly burn coal in home. Okay, to to generate heat, okay, because they are so cold in winter, okay. The second, and petroleum and natural gas, they are the same, the source are the same. The differences of petroleum and natural gas is gas because it has very small molecule. And petroleum, they are liquid, okay, because they has a large molecule. The structures are they are similar, and the source they are similar, okay. And petroleum in different country they will be called different names, okay. In England, it is called petroleum. In America, it is usually called oil or sometimes called crude oil, okay. It is not the same as the oil we are using to cook, okay. But in America, it sometimes also called oils. They are the same, okay. They actually petroleum is not a pure substance. It's not pure. It is a mixture. But the mixture, the different kind of substance inside, they are relate to each other. They are similar compounds, but they are not the same. Okay, so remember, it is a complex mixture, very complex. Okay, complicated. Okay, and those compounds usually contains two elements. They are carbon and hydrogen. So they have a general name of hydrocarbons. That means it is compound with mainly hydrogen and carbon. So why they are called hydrocarbons? Okay, so learn this work because we later we will always talking about hydrocarbons. That means compound with carbon and hydrogen as the main components. Okay, and natural gas. Actually, they are gas. No, they are also hydrocarbons, but because their molecule is smaller, okay, so they are in form of gas. Still remember the relations of the size of molecule with the boiling point. Because the size of molecule is small, there are van der Waals forces between or among the molecules are small too, so they cannot maintain as liquid in normal temperature and pressure. So they will change into gases. Okay, but the formula are similar. And one of the main components in natural gas is called methane. Okay, methane is one of the uh, carbon compounds. You will be learned in later chapters. Actually, you will be learned how the name is come from and how to relate the name with its formula. Actually, it is CH4. Actually, in daily life, you always uh, you may heard this name very frequently. Okay, actually in Chinese it is called 甲烷. Okay, it is one of the gases. Okay, in petroleum gas, liquefied petroleum gas, or in town gas. Okay, the main components. Okay, methane. It is the main component in natural gas too. Okay, and how natural gas and petroleum is formed. Actually, the source is similar. It is also covered by soil, and it is also receive high temperature, high pressure, and also action of bacteria. But remember the differences of the source is different with coal. Coal is from plants, okay, but petroleum is natural gas are aquatic living organism. Aquatic means in sea, in water, okay. When those animals in water, they die, they are uh, covered by soil and the actions of high temperature, high pressure, and also actions of bacteria, they will slowly turn into hydrocarbons. Okay, remember, plants become coal, and living organism. Okay, usually animals, sea animals. So if you forget to spell how to spell aquatic living organism, you can just say sea animals. Okay, they all usually come from sea animals. They will turn into hydrocarbons, petroleum, and the small molecules of petroleum is natural gas. Okay, similar. The diagram just show you how you can you find petroleum in our Earth. Okay, and how to extract petroleum. Even we can also extract petroleum from sea. Okay, but before the fossil fuels being used, okay, coal can be directly being used. Also, although it contains some impurity, sulfide. But if you burn it, usually it can still be used, okay, directly. But petroleum is a little more complicated. Actually, the human discovered petroleum a long, long time ago. They when they dug into the earth crust, they found out some liquid which is dark, okay, which is black in color, and they burn it, okay, but a very bad result because when you burn it, it will produce a lot of dark soot, dark soot, okay. Soot is similar to smoke. Okay, if you write down smoke is also acceptable in examinations. Okay, and also it will produce acidic gas. So even several hundred years ago, human discovered petroleum, but only in the recent 100 years, human use petroleum more frequently. And why? It is because if we directly burn petroleum, we will produce these two bad things. Okay, and these two bad things will result very bad or serious air pollution. Okay, because both two substances are air pollutants. Okay, so why the reason 100 years we can use petroleum? It is because we know how to refine refinery. Okay, in Chinese, 精炼. That's mean we try to make it more fine. Okay, fine, refine, okay, and make it better, okay. And the most important process in refinery of petroleum, actually usually two process in refinery petroleum, and the first process is fractional distillation. It is the refinery first process, and the second process in later chapters you will learn it is called cracking. Okay, when we are talking about refinery of petroleum, we are usually talking about these two industrial processes. The first process is fractional distillation, and the second is cracking. Cracking, you may not know what is the meaning of cracking, but fractional distillation, you have learned it in previous chapters, right? Fractional distillation is a physical method, physical separation method. Okay, actually distillation is a separation method. Okay, but factory distillation is more uh, suitable in separating mixture. Okay. Okay, because petroleum is a mixture, so we need to separate it. Uh, Part of the mixture is useless, and when you burn it, it will produce a lot of soot and acidic gas. So we need to separate it. We only obtain those fractions that part those components which are going to use. Okay, the following diagram showed the use of fractional distillations for petroleum. it is a mixture. You can see in the diagram there are different kind of molecules. Okay, actually you can see the molecule. Actually, this molecule, the shape of the molecule or the diagram of the molecule is showing how can we one kind of method to try to represent those molecules in petroleum. Okay, you can concentrate on the number. Actually, the number tells you the molecule contains how many carbons. So C1 means that it is a molecule contains one carbon. Okay, and C4 it is a molecule contains four carbon. So you can see that in petroleum, there are so many different kinds of molecules contain different number of carbons. And actually, in later chapters, we will learn that carbon compounds they usually differ from the number of carbons they have. Okay, so actually, why they are represented by C14, C17, so on and so on. So actually, petroleum contains maybe C1 to C maybe 28 or sometimes go to 30. Okay, and because different molecule they have different properties and the usage of the different uh, molecules is different. So we need to separate them first. Because they are liquid mixture, the most common method is using fractional distillations. Okay, then they can be separate into different fractions. The different fraction means different parts. Okay, because in fractional distillations we will separate the mixture into different parts. So usually those parts are called different fractions. Okay, that's why it's come from the name fractional distillations. Okay, uh, uh, molecule with similar size, they will be separate. It is of course it is the best to separate them into separate compound, but the cost will be much higher. So usually only molecules with similar size will be separated in the same fractions. Okay, of course you can further separate it, but the cost will be higher. So you can see maybe molecule with 1, 2, 3, and 4, C1 to C4 collect in the same fractions. Carbon with C5 to C maybe 8 collect into the same fractions, so on and so on. Okay, the actual setup to do the fractional distillation is like this. Okay, in some country they will have some petroleum refinery factory. Okay, and if we want to doing some fractional distillations, we the factory will contain a fractional column. Okay, the column is like this, and the size of the column is actually very large. Okay, such column actually the height the height is similar to maybe a building with 5 to 6 floors. Okay, so it is actually very large. Okay, and when we want to do some fractional distillation of the petroleum, we will input the crude oil, the petroleum, into it. It is then being heated. Okay, and the temperature required may be up to 400 degrees Celsius. It is because the largest molecules in petroleum, they if you want to make it boil, make it turn into gas, you need such a high temperature. Of course, the largest molecules turn into gases, the smaller one will also turn into gas. Okay, and the heated petroleum go into the tower. Okay, the column, and because it is gas, okay, it will have a tendency to go upward. Okay, when it go upward, okay, through this hole, then there is a cap here. The cap try to restrict the gas to further go into the highest part. Okay, and because the temperature in maybe the first layer will decrease because only heat the petroleum is only heated here. So when it reach a higher position, the temperature decrease, and because the temperature decrease, the molecule with a higher boiling point will then turn into liquid. Okay, so in here, this layer, those molecules with higher size will condense, will turn back into liquid. Okay, and the later, okay, gases will also goes into it. You can see this diagram. Okay, the gases will pass through the liquefied petroleum. Okay, the liquid, the hydrocarbons which has already been condensed. Okay, and heated it. It will make those uh, accidentally condensed with a small size molecule will also boil again. Okay, and such design can help to more effectively separate different fractions. Okay, and because the temperature is already reaching this range. Okay, so those fractions with boiling point close to this range will maintain in these fractions, but those molecules with lower boiling point, they or even accidentally condensed, they will reheated by the gases come go through. Okay, then it will bring upward again. Okay, through such kind of hole, and it prevent the separations. Some of the smaller molecule will maintain in these fractions. Okay, repeatedly doing such heating. Okay, but in the upper part, the temperature will further decrease. Okay, then only fractions with boiling point close to this range will maintain in these fractions. Similarly, molecules with even lower temperature, lower boiling point will maintain in these fractions. Then the tower help the molecule, the hydrocarbons to be separated into different parts, okay, with different boiling point range. Okay, but of course, such method cannot completely separate different kind of hydrocarbons. You can see we try to separate them into different fractions with a close molecule size and close boiling point only. Okay, and finally, those fractions they are in under 40 degrees Celsius still maintain as gases. They will collect in the highest part. Okay, such method is called fractional distillations. Mixture is heated, and then during different fractions they will be reheated, and because in the different fractions the temperature range is different, so they will be slowly separate into different fractions. Okay, out of this picture, several things you must need to remember. One, the most difficult one is the name of different fractions. The highest part, it is called fuel gas because they are gas. They are most of the most useful usage of such of gas is to become fuel, so they are called fuel gas. And because they are come from petroleum, so the common name of the fuel gas is called liquefied petroleum gas. Actually, in room temperature and pressure, they are gas. They come from petroleum, so why they call petroleum gas? But because to making use or to more convenience to transport and to storage, they usually being liquefied. Liquefy means that make them become liquid. Or sometimes, if you forget how to spell liquefied, you can just say liquid petroleum gas to describe that the status it is in liquid. Okay, so the most common fuel gas is liquefied petroleum gas. It contains hydrocarbons with one carbon to four carbons. Okay, and it has the lowest boiling point. Okay, the second fractions, usually you can find it further divided into two parts. Actually, it contains gasoline. It is used to the car fuels. Okay, the carbon number is close to maybe 8. Okay, C8, and the uh, hydrocarbons with more carbon. Okay, maybe 9 to 10. It is called naphtha. Naphtha. Okay, it is the important raw materials for many making many carbon compounds. And also in Hong Kong, uh, one of the gas being used in our domestic use is town gas. Okay, the town gas actually in Chinese is called 煤氣, but it is not come from coal. Actually, it is come from naphtha. Okay, the use of naphtha is to produce town gas. Okay, and higher fraction it is called kerosene. Kerosene is a common fuel being used in Hong Kong, but 40 years ago. Okay, but nowadays we usually use it as aeroplane fuels. So remember to use. So in this diagram, several things to be remembered. First of all, name of different fractions. Second, the use of different fractions, and also the progressively changes of properties, especially the temperature of the boiling point. Okay, but no need to remember detailing the boiling point. Just remember the tendency of changing of boiling point. Smallest boiling point, highest boiling point. Okay, they are changing. Okay, it is one of the properties you must remember. Okay, next of kerosene is called gas oil or diesel. Okay, it is used as industrial fuels and also bus or trucks fuels. Okay, and higher it is called fuels oil. It is used in industrial ship and power stations. Okay, and the one it cannot be changed into gases. They keep in liquid even in 400 degrees Celsius. They will drop into the bottom. It is usually used as lubricant and wax. Okay, and the largest molecule they are vitamin. Okay, 拍油 lectin. Okay, so actually this diagram several things to remember. Name of different fractions, name, use of different fractions. Okay, and also tendency, change of properties. Quite a lot of information you need to remember. Okay, uh, but this setup, although it is used in industry, but we cannot set up such things in a school laboratory. So sometimes the past paper, the examination paper will ask you if you also want to do a factorial demonstration to separate different fractions in petroleum. How can we set up the apparatus in school industry? It's in school laboratory. Well, don't draw this one. Okay, we should draw the setup you have already learned. Even in our laboratory, we can do fractional distillations, but using this setup. Okay, a simple distillation, simple setup to do fractional distillations. But of course, it cannot automatically separate different fractions. We should put a thermometer to look at the gases. Okay, the temperature of the gases to predict which gases is coming out, which is the fraction we want to collect. Okay, so depending on the temperature of the gas form, we collect different fractions. So we must change the test, keep changing, uh, dependence on temperature. Okay, and we can separate different fractions. But in examinations, if you asked to draw the sap, you can draw like this. Or still remember, the sap can also be drawn like this: the thermometer and a delivery tube. Okay, simple drawing. And some detail part, for example, we are not putting the petroleum solely in the test tube. We usually use some rod cell. Okay, rod cell is something like cotton, but it is not cotton. The shape is like cotton. The outlook is like cotton, but it is some minerals. Okay, it can use to salt petroleum. Even after heating, it will not react. Okay, so it is called rod cell. Okay, to salt the petroleum so that the petroleum will not boil, okay, and it will slowly turn into gas. And also because the petroleum gas is the temperature is quite high, so we need to condense it using a water bath. Okay, depends on the temperature, we will collect different fractions. So remember how to draw it. Okay, and I have told you that the different fractions, several things you need to remember. Actually, you can use this table to remember it. The name of the fractions according to the temperature, the boiling point. Uh, Usually, how many carbons contains, and the use of the uh, different fractions. Okay, some students will think that oh, it is quite difficult to remember the different fractions. Okay, some people will suggest you to try to use the first letter to remember it. Okay, so the latest, the smallest fractions is F. F, G, N. It is F, G, N, K, G, F. Okay, try to make use of the first letter to build up a sentence to remember it. Okay, maybe okay. So and also the change of properties. You can also see this table. Okay, but usually you are being asked several things only. Okay, change of boiling point. You may predict it by the size of the molecules, but actually some new terms, maybe it will be asked in public exam. Okay, the first term is volatility. Okay, it is how volatile it is. Okay, so if the boiling point is increasing, the volatility is decreasing. Okay, that means it will evaporate. It will change into gas more difficult. Okay, that means if you put it in open areas, okay, it will not turn into gases easily. Okay, so else of else you say easy to evaporate. Okay, the size is increasing, then it is more difficult to evaporate. So the L's of uh, evaporations will decrease from small molecule to large molecule. Okay, or the volatilities will decrease from small molecule to large molecules. And the color. Okay, usually the fractions with small size, they will be after the fractional distillation. Even petroleum is black in color, but after separating fractional distillations, then the smaller molecule will become colorless because hydrocarbons actually do not contain any color. Why petroleum contains color? It is because it has some impurity. The impurity is carbon, and carbon because it is solid. So you can predict that carbon will remain in fractions with higher size of molecules. So you can see the largest molecule, they will still maintain a dark color, maybe brown, okay, maybe black, okay. But the smallest molecule, it should not contain any carbon, so it is colorless. But the larger fractions, they may contain a little amount, so it will still maintain a pure yellow. And the fraction size increase, the impurity increase, so the color will be more dark. Okay, and then the next one, it is viscosity. Viscosity is how sticky. Okay, sticky. Actually, it is related to the van der Waals force. The highest the van der Waals force, the highest the viscosity. It is called viscosity. Actually, how sticky it is. Okay. You can relate it into the simple molecular uh, properties. Okay. The van der Waals force. That means the larger the size, then the largest the van der Waals force, then it is more sticky. That means the viscosity increase. Okay, so fairly viscous, quite viscous, and not viscous. Okay, just like water. Okay, uh, and the next property is flammability. That means can it easy to burn? Okay, actually for hydrocarbons, the smaller size, the easiest to be burned easily. Okay, so you can predict that size smaller, they can be burned uh, more easily. Larger size, they are more difficult to burn. Okay, and the largest one, when you burn it, will it produce some soot? Okay, so sootiness. That means producing soot, and the color of the uh, soot and also the flame. Actually, when you burn a hydrocarbons, why sometimes the uh, fire will become blue in color? It is because when the hydrocarbon or the fuels being burned is completely burned, then more temperature, more heat energy is produced, then it will become blue in color. But if the fuse is not burned completely, it will still maintain or contain some carbon. The carbon in a hot flame, it will turn into yellow color, so it will make the flame yellow. Okay, so yellow or orange. So you can see uh, for smaller hydrocarbons, it will burn with a blue flame. Okay, sometimes it is still yellow, still remain some carbons. Usually no soot. Okay, that means all carbon are burned into carbon dioxide, no carbon contained in the flame. But for larger molecule, it will still contain some unburned carbon or a lot of unburned carbon. So the flame will be yellow or orange, and it will be very sooty, very a lot of smoke. Okay, so it is the general changes of properties. No need to remember detailedly, just remember the tendency. Remember the tendency. And usually they are only being asked in MC. So just remember the general tendency is enough because you will be given some choice in examinations. Okay, so the general things you must remember, it can be concluded in this page. Okay, and it's the end of the second part. For these chapters, no homework, but still remember for chapter 19 you have 5 questions to answer. Remember to answer it. Okay, so it is the end of today's lesson. Let's see each other next week. Okay, bye bye.